Okay, today we're going to talk a little bit about food webs and biological cycles. So, some of this stuff should be reviewed. Talked about it a little bit before. But this is what we would call a food web. Right? It shows the relationship between organisms that eat things and organisms that are being eaten and all that.
If Julie's not able to do it, then we're sure don't have to do it. It is Friday, there's no class.
All right.
Apparently wrong. Oh my gosh.
All right, let's focus here, please.
There's no house class.
The longer you string it out, the worse it'll be.
Okay, is it going to be quick or is it going to take a long time?
It's taken a long time so far. So, food chains is something you hear all the time, but food chains are not a good way of showing how an ecosystem interacts. Right? A chain in which one organism eats the other doesn't show the fact that, like, a hawk is going to eat all sorts of different things. A fox is going to eat all sorts of different things. Okay? Plants are going to be eaten by multiple organisms. So a web really shows the interconnectedness of an ecosystem. And when we start looking at organisms in a food web, we can separate them into two main groups. We've talked about these before. Down here we've got autotrophs. And what do we call these? Heterotrophs. Okay, if you remember, troph means food. Auto means self, so these are organisms that make their own food. Hetero means different. These are organisms that have to get their food from different sources. They have different things. Anything that doesn't use either sunlight or chemicals to make their own food would be a heterotroph. But there are some things that we don't necessarily think of as heterotrophs, like fungi, mushrooms. Do not make their own food. They look sort of like plants, but they have to eat stuff. They have to break things down. So those are examples of heterotrophs as well. Okay. Now, as far as energy goes, if you remember, as you move up through each trophic level, only about 10% of the energy is able to move on. Okay, we've talked about that before. So there's huge energy losses, and that's why food webs can only be so complex. You can't have organisms eating organisms too much down the line because there's just not enough energy that's left over. And that also tells us that these organisms up here, as you move up, they have to eat a lot as far as the number of organisms. There is a large number of organisms being consumed. As far as the top organisms have to eat a lot of the organisms underneath. So it takes multiple rabbits to feed, say, a hawk. A rabbit's going to have to eat a whole lot of grass in order to feed itself. And so if you think about how many blades of grass go into sustaining a hawk, there's a huge amount of that because of that, what we call that magnification factor.
Would we be the top planet though?
Generally, yes. I mean, depending on what we eat, we may not be quaternary consumers because, again, we're going to sometimes be at this level because we may eat plants, right? We're omnivores. But sometimes we'll be up here because we eat something that's eating something else. Okay? So here's an example of a food web. So in certain food webs, we do give different names to organisms depending on their eating style, right? We call these organisms up here carnivores because they only eat meat. Carn means meat. Organisms down here would be herbivores. omnivores because they only eat plants. And then something like the tundra swan, which is going to eat both, we would call omnivores. Because they eat both.
Is it important to know what animals are carnivores and what animals are carnivores?
Like on this diagram? No, I'm just using
like,
I'm just using these as examples. Yeah, I mean in general. So bears would be examples of omnivores as well. They'll eat plants in some cases. Eat more meat than plants. Dogs are an interesting case because we consider them to be carnivores, right? Wolves in the wild, they just eat meat. But they're not locked into that. Cats are what we call obligate carnivores. They can only eat meat. But dogs, a lot of times, the food that we feed them, isn't necessarily meat. We can take scraps and stuff like that. And also, a lot of their dog food has rice in it. Well,
gosh, ours does too, actually. So then it gets diarrhea.
Yeah,
too much grass.
that tends to be.
So dumb.
When dogs eat grass, it tends to be because they've eaten something that doesn't agree with them, and they're trying to eat a lot of the grass to help them get rid of that. So it's not really for dietary needs. Okay. And then there's another term that you may not have heard of before called a detritivore.
That just sounds
Detritivore eats dead things.
Really, Carly? You want to be like, we do technically dead. Yeah, we do.
Well, things that are already dead. Like fish, they're dead. Yeah.
So
they may be dead. Yeah, we may kill them and eat them. But we're talking these are organisms that eat things and break them down. They're
like vultures.
Decomposers. Yes, like vultures. So most of the detritivores that we find are going to be in the fungi and bacterial families. But there are also lots of insects, carrion beetles, and domestids. Excuse me. And then, of course, vultures. That we think of a lot of the time.
So if there's like some inland on the side of the road, that's
right. Things that have been dead and are decaying. Yeah. They don't kill their own food.
They just let the cars do that themselves.
Right. Okay, so there's just a few terms that we throw at these different organisms based on what they eat. Okay, one thing that we see when we look up the food chain, or the food web, but this is simplified into a chain just to make it a little bit easier to look at, is something called biomagnification. Well, it goes back to that thing that we said, okay, if a hawk has to eat this many rabbits and a rabbit has to eat this many blades of grass, think about all the blades of grass that have to go into feeding that hawk. Well, think about it, every one of those blades of grass had a little bit of some sort of toxin in it. Now, if a rabbit eats it, it may not affect the rabbit that much because the rabbit's only eating so many blades of grass. But for the hawk, who's eating lots of rabbits, all of those chemicals tend to stay in the organisms as they pass it on. It's not like the energy that gets dissipated and lost. Those chemicals stay around. So that as things move up the food chain, the concentration of the chemicals gets more and more. And we actually saw this to quite an effect in using DDT. Has ever heard of DDT?
No.
So DDT was a pesticide. It's an insecticide that was used to in fields and stuff, but mostly to control mosquitoes. And it's very good at controlling mosquitoes. Problem is, it gets into the water and it gets uptaken by certain little organisms, microorganisms in the water that fish eat, and then bigger fish eat those, and then hawks and eagles eat those. And every time it moves up the food chain, it gets more and more concentrated because one organism is consuming lots of other organisms. So by the time it gets up to that level, it's at high enough concentrations that it actually affects those top level predators. And so what we saw was that in hawks and eagles, when we were spraying them this DDT, in hawks and eagles, we saw that their shells, the shells of the babies, were not robust enough to keep them in during their whole incubation time, and so they break open too early, and most of the little eaglets were dying before they were actually born. So we recognized the problem, and DDT has been banned in the United States for decades now. We've seen that problem largely go away. Question?
Is that like kind of the same with like mercury, like if you eat fish sometimes?
Right. That's why they tell you not to eat fish every meal of the day. They say I'll only eat fish once a week, because the more you eat of it, the more of that you're putting in, and it takes time for those toxins to dissipate. Okay. Oh, and so biomagnification is going to generally affect top-level predators most. If it was actually affecting these fish and it was killing these fish down here, it would never actually get into those top-level predators. Because it's in such low concentrations in those fish, it doesn't affect them. It only affects the things higher up the food chain. Okay, the next thing we're going to talk about are the different biological cycles. There's 4 main cycles that we see that are important to life. There's the water or the hydrological cycle, the carbon cycle, the nitrogen cycle, and the phosphorus cycle. So each of these cycles are different ways that certain chemicals, water is a chemical, everything is a chemical, but these certain chemicals move throughout our ecosystems and get kind of turned from one thing into another and then back. They're cycles because they cycle around themselves.
Are you partial to a nitrogen cycle? That's why we do that one.
I don't know if they're not partial to it, but it's an important one to understand. Water cycle is probably the one that is most familiar to you guys, right? Mm-hmm. Water evaporates, turns into clouds, it condenses, precipitates, and rains, runs into everything.
That's actually the only thing you learn in elementary science. Every year. That's the only thing.
All right. Well, there is a major part of the hydrological or the water cycle that doesn't tend to be hit as much in elementary science, but maybe you guys already know it. And that's the fact that water, as it moves through plants, there's a big part of that cycle that happens. And they don't show it on here, but there's uptake through the plant roots. And then that water is lost through the plant leaves through a process called transpiration. You guys ever heard of transpiration before? And that's an important process for plants for moving nutrients up through their roots. They do use some of the water for their processes, but it's the evaporation, the transpiration of water out of their leaves that helps draw more water up through the roots, which moves other nutrients and minerals up to the plants for them to use.
So is there enough water from the plants that cause like clouds too?
Yes. And so major rainforests, there's so much humidity loss for those that they actually cause their own little part of the weather cycle. Okay. So uptake through roots and transpiration, that's part of the water cycle. We probably don't need to cover much of the rest of that. It sounds like you guys know it already.
We have a song.
Oh, absolutely.
No, it won't.
You volunteered.
I don't even know the song. Me neither. I don't.
and say that this was something that Mr. Piasky showed you on a video and not saying himself.
Yeah.
You can look it
Yeah.
up. That'd be so funny though. I would pay money to see that.
Alright, the next cycle we're going to talk about is called the carbon cycle. Okay, the major part of the carbon cycle from a biological standpoint, of course, is that trees or plants take in that carbon dioxide and they turn it into their structures. Plants are built from carbon dioxide. Yes, other things, but their main structures, all their leaves and everything, are carbon compounds, and all that carbon comes from carbon dioxide. So if you watch a plant grow over time, they're basically building themselves out of the carbon dioxide that they take out of the air. Okay? When you eat a piece of lettuce or a cucumber, you are intaking that carbon, your body breaks it down, and turns that carbon into more of you.
So we're part of the carbon cycle?
Absolutely.
Oh.
If a lion kills you and eats you, it's going to take that carbon and break it down and make it more lion. So, as the lion is slowly snuffing the life out of you, you can at least revel in the fact that you'll be part of a lion.
Cool.
Wow.
Okay.
When you think about that one,
That's a, always look on the bright side.
So what about when you die and you go on the ground?
Okay, I'm getting to that.
Okay, sorry.
So, whether or not, so some plants, of course, are just going to die and not necessarily be eaten. But if you eat a plant and then you die, or something eats you, and eventually that organism is going to die, and its body is going to decay. And during decay, bacteria and sometimes fungi, but mostly bacteria, different detritivores, are going to break up that carbon and release it back to the atmosphere as carbon dioxide.
Except for that's bad. We don't want it to be released back.
Well, this cycle, part of the cycle right here, is fairly set. This is the problem over here. The burning of wood fossil fuels is adding that much more, which can't be uptake because, of course, we're cutting down all sorts of forests as well. But the major part of the biological side of the carbon cycle, anyway, is this uptake of carbon dioxide. And the thing is, we do release some carbon dioxide through our breaths as well. Through breathing, we're giving off some of that carbon dioxide back.
Don't breathe and then you won't release carbon dioxide.
Then you
save the earth.
more.
You could save the earth though.
But,
I want no breathing.
all right. Eventually, no matter what happens, eventually that carbon dioxide will be released. All the carbon that's in your body will make it back into the atmosphere at some point. So decomposition releases CO2. So eventually that carbon dioxide is going back. Breathing is not going to help, or not breathing is not going to help, I should say. If you really want to save on carbon dioxide, you should you listen. Let's try to put words in my mouth. It's hard to think of the ones that I want to use. You should offset your carbon dioxide output by planting trees. Yes.
There's a lot of Wait a minute. Oh, speaking of, there's like this new thing where you put your ashes in it and it grows into a tree. Yeah.
That's cool.
You put your body.
It's new technology. But it's like if you get cremated and you bring yourself to Italy or something, and it's somewhere over there. You fly yourself to Italy. Yeah. While you're there, then they connect you into a tree. And then they plant you, and then you become a tree. That sounds so complicated.
I mean, all right, here's the thing. You're not going to be around anyway, and eventually you're going to end up as part of a tree or a plant anyway. So.
Yeah, but why not?
The tree is part of you. The tree is you.
Like you're
But isn't that
That's my great grandpa.
Everybody don't like my tweet because I said quit breathing safe beer.
Okay, the next next one I'm going to talk about is the one you guys did your homework on. This is the nitrogen cycle.
Yeah, that's right. Thanks for the retweet. I appreciate it.
I found my thing about it.
So, the atmosphere is like 70% nitrogen. I'm glad it is. The atmosphere is 70% nitrogen. You need nitrogen. Unfortunately, your body is not set up to take any of the nitrogen out of the atmosphere. You breathe in all sorts of nitrogen into your lungs when you take a breath. Every bit of that nitrogen comes right back out eventually. So, I mean, it does dissolve in your blood and make its way around, but none of it actually gets used by your body. But we have to have nitrogen.
That's so unproductive.
It is. It would be great if we had some sort of structure that was able to use that nitrogen, but we don't.
Someday we'll evolve.
So, the way we get our nitrogen is by eating things. Okay? So, we are able to eat organisms that have the nitrogen in those, and through amino acids break those down and use them.
So we do use them, or other organisms.
Yes. There are some, well actually they're not even really plants. They're bacteria called nitrogen-fixing bacteria that live in the root nodules of some plants called legumes.
And the bacteria use the nitrogen.
So, plants like soybeans and peanuts, on their roots they have these little areas called nodules that have bacteria in them. They're separate organisms, but they live in a symbiotic relationship. We'll talk more about symbiotic relationships on Monday. And they are able to take nitrogen from the air and turn it into a form that the plants can actually use and take up through the roots. So I don't know, those of you that know a little bit about farming, you don't put nitrogen fertilizer on with soybeans because they basically have these bacteria that make their own nitrogen. Yes?
Hi, I was reading a study a while ago, like 2 years ago actually, and it said that the nodules only form when the soil is missing nitrogen, but then the nitrogen doesn't actually go into the plant that grows the roots.
It doesn't go into the plant that grows.
Yeah, it doesn't help the actual plant. It helps like the next generation, like the next one. It was like a legit thing. It was done by a professor.
Okay. I don't disbelieve you. I don't know. It doesn't make a whole lot of sense. Yeah.
I believe it.
I don't know. I'll have to look into that. So anyway, this nitrogen gets broken down by these nitrogen-fixing bacteria. It gets into a form that any plants that are using the soil are able to use. And so it's uptaken and entered the biological cycle that way. Now there are other types of bacteria called denitrifying bacteria that actually take some of those compounds that the nitrogen-fixing bacteria have made and turn it back into the atmospheric nitrogen. So the main parts of the kind of overall cycle here are bacteria taking it from the air and turning it into a form that can be used, and then other bacteria turning it back into the atmospheric nitrogen. But as long as it's in that form that other organisms can use, then plants can take it up, it can enter the biological cycle, and it can be used by other organisms. Okay? Yes?
We're talking about how we're not going to remember any of this because we're over it.
It's a good thing I'm recording this then.
Oh, good. Oh, good.
And then the last cycle we're going to talk about is the phosphate cycle, or the phosphorus cycle. Phosphate is just the form of phosphorus when it's in a compound. Phosphorus cycle is a lot longer, or time-wise anyway, because the phosphorus that we need in the biological cycle is only given off by breakdown of rocks. So as rocks break down, as they're weathered and break down, they give up phosphorus into the soil. That can actually be used by plants, which then of course we eat. And when we decay, it gets given back into the soil. Over time, the way sedimentary rocks form, that phosphorus can get trapped back into rock, and then the whole process has to go on again.
So it's a slow process because the phosphate's trapped.
Right. It's a slow process because the phosphates, when it's not part of the biological cycle anyway, it's trapped in the rock. And so as far as the biological cycle is concerned, we've got this just kind of circular pattern between living organisms, decaying organisms, putting it back into the soil, living organisms, decaying organisms. But any new phosphorus has to come from the breakdown of rock.
So do we become rocks after we're buried?
Only, I don't know. It depends on what you call wheat. Yes, there are some atoms that will end up in rocks. There's some that will end up in the atmosphere. There's so many atoms in you that probabilistically, there's going to be some that end up everywhere. Every drink of water that you take, there's at least one atom that was in a dinosaur at one time.
What? Oh my god, I'm done. You didn't tell us. You didn't think you should tell us.
Here I am becoming a dinosaur.
Drinking a dinosaur.
Wait, you should repeat that again. I don't remember it.
Okay. Every drink of water you take, there's at least, probability-wise, there's at least one atom in there that wasn't a dinosaur.
I'm drinking one dinosaur. I watched Jurassic World last night.
I did Jurassic World this weekend. It's so awesome.
It has
Chris Pratt in it.
That's good.
All right. That's all there is about cycles.
Yay!